And welcome back everyone to Cajun Coding. We're still working on the Logic1 series of exercises on Nick Perlente's site Codingbat and studying Java. We left off with Fizz String and are now on the exercise Fizz String 2. And the instructions for this problem are: given an int n, return the string form of the number followed by the exclamation point. I'm going to call it the exclamation point. We're just printing stuff out. We're not using using it as a logical operator. So the int 6 yields 6 exclamation point. Except if the number is divisible by 3, use fizz instead of the number, and if the number is divisible by 5, use buzz, and if divisible by both 3 and 5, use fizzbuzz. And of course it gives us the reminder we can use the modulo operator for that. Okay, so if, oops, I don't have focus over here. I don't know where my cursor was. Okay, so if n modulo 3 equals 0 and n modulo 5 equals 0, return fizzbuzz and I think we are putting an exclamation point on there. Oops. Use else if. And we see divisible by 3, that's fizz. Okay, and the default would be return the number itself, and then we're going to use the concatenate to add the exclamation point on it. And of course the logic behind this is very similar to the previous fizzbuzz problem. We need to check to see if the number is divisible by both, or if the condition, I should say the condition, if the condition is both, then we return something. If the condition is only one or the other, then we return that, and then we have a default state. And the next problem, 2 as 1, given 3 ints, a, b, and c, return true if it is possible to add 2 of the ints to get the third. Let me see. I'm wondering if there's something in particular, then some direction, programming wise, that they're trying to lead us to. And it looks like it's just a simple series of if statements. So if a plus b equals c, or b plus c equals a, or a plus c equals b. Actually, we don't even have to use the if. We can just return. That should be it. Oops, I clicked the wrong button there. In order, given 3 ints, a, b, c, return true if b is greater than a and c is greater than b. However, with the exception that if B OK is true, B does not need to be greater than A. Okay, now the B OK we have is a Boolean that's being passed in. So this is, as with many of our problems, an alternate conditional that we need to check. So let me see. So if B OK is true, then B does not need to be greater than A, but C needs to be greater than B. Return C is greater than B. And this would be return B is greater than A and C is greater than B. And that satisfies all the conditions. And the next problem, in order equal, given three ints a, b, c, return true if they are in strict increasing order, such as 2, 5, 11, or 5, 6, 7, but not 6, 5, 7, or 5, 5, 7. However, with the exception that if equal OK is true, equality is allowed, such as 5, 5, 7, or 5, 5, 5. And this one looks pretty simple as well. So we're going to go ahead and do if equal OK, return B is greater than or equal to A, and C is greater than or equal to B. And then if equal OK is false, then return B is greater than A, not equal to, and C is greater than B. That should be it. Yep. Pretty easy. Still in the first section for logic problems. Given three ints for last digit. Given three ints A, B, C, return true if two or more of them have the same rightmost digit. The ints are non-negative. And note the modulo operator computes the remainder, that is 17. Modulo 10 is 7. So any number modulo 10 will give you the rightmost digit there. So return if two or more of them have the same rightmost digit. So let me see. Return A modulo 10 equals A modulo, excuse me, it would be B modulo 10, or B modulo 10 equals C modulo 10, A modulo 10 equals C modulo 10. And it should do it. Now, I might not get into that. I suppose we could. You notice that the modulo 10 would give you the rightmost digit. Now, how, for example, would you get the tens place digit? Well, the answer to that would be you would use division, but you would use integer division, which is the default when you're computing with integers. So if you use, anything divided by 10, it would give you the tens place only. So, and there might be some problems coming up that use that. Given three ints, A, B, C, return true if one of them is 10 or more less than one of the others. me see. So it looks like this would be a good candidate for our absolute value. So if we return math abs and then a minus b, and that would be, see, 10 or more, so it would be greater than or equal to 10, or math abs b minus c greater than or equal to 10, or math abs a minus c is greater than or equal to 10. That should do it. And what kind of hint did they have for us? There are just 3 pairings, A, B, B, C, A, C. Detect if the difference in one of these pairs is 10 or more. So, and that's what we did. Okay, and next one, without doubles. And here we are with the next exercise. This is without doubles. Return the sum of 2 6-sided die rolls, each in the range 1 to 6. However, if no doubles is true, then the 2 dice show, if the 2 dice show the same value, increment 1 die to the next value, wrapping around to 1 if its value was 6. So, let me see. If no doubles, and then we're going to check to see if the dice are the same. So die 1 equals die 2 and if that is false, then we're simply going to return die 1 plus die 2. Now if it resolves to true, and we're disallowing doubles, then we do need to check on, let me see. And what this is, if die 1 equals 6, now I already checked to see if they're equal. So if they're equal, then we know that both of the dice, if die 1 is 6 and they're both 6, in which case we're going to return 7 because one of the 6's becomes a 1. And I don't think I want to work this out here. And otherwise we'll return die 1 plus, actually we could do die 1 times 2 plus 1, because we'll be incrementing the die, one of the dies up by 1. And we've already checked for double 6's. And that should be it, I believe. Missing return statement 13. How did we get that? Okay. Got those nested ifs there. Okay, if no doubles. Yeah, I don't think we did. We didn't do if there was no if doubles. Okay, else return die 1 plus die 2. And there we go. Had several if statements there, and sometimes it gets to be a little bit hard to tell where we are in the code. Do remember, if you click on the closing brackets, the opening bracket for the one you click on will show up. See? Okay, and on to the next one. Max mod 5, given two int values, return whichever value is larger. However, if the two values have the same remainder when divided by 5, then return the smaller value. However, in all cases, if the two values are the same, return 0. Note that the mod operator computes the remainder, i.e. 7 modulo 5 is 2. So now this does say in all cases if two values are the same, return 0. So let's go ahead and get that out of the way first. Now return whichever value is larger. However, if two values have the same remainder divided by 5, return the smaller. Okay, so now we've got another if A modulo 5 equals B modulo 5. Now it says if the same remainder when divided by 5, return the smaller value. So we're going to return the smaller of the two. Okay, so that would be math min a b, and then we use the else if they are not, the remainder is not the same, so we'd be returning the larger max and passes all tests. Red ticket. If you see, not if, rather, it says you have a red lottery ticket showing ints A, B, and C, each of which is 0, 1, or 2. If they're all value 2, the result is 10. Otherwise, if they're all the same, the result is 5. Otherwise, so long as both B and C are different from A, the result is 1. Otherwise, the result is 0. And we can basically just set this up as a series of if statements. They're all value 2 if A and B and C all equal 2. Return 10. Otherwise, and let me see, we'll just use the else if. If they're all the same, result is 5. So A equals B and B equals C. And otherwise, so long as both B and C are different from A, so that would be A not equal to B and A is not equal to C, the result is 1. And otherwise the result is 0. I wonder if they give a solution for this. I really don't see any other way to do this. This is a good just practice exercise, just for learning how to phrase those statements and such. And do remember when you're doing things like this that you want to start with the most expansive conditions, and then go down to more specific ones. Or, for example, the second condition, A equals B and B equals C, Well, that is also the case if A equals 2 and B equals 2 and C equals 2. So we need to capture the all 2's before we test to see if they're all the same but not 2's. So, and it's just something that comes with practice. Next one is green ticket. You have a green lottery ticket with ints A, B, and C on it. The numbers are all if the numbers are all different from each other, the result is 0. If all the numbers are the same, the result is 20. If 2 of the numbers are the same, the result is 10. So if the numbers are all the same, so let's go ahead and check that one first. If A equals B and B equals C, we actually don't have to check A equals C, since if A equals B and B equals C, then obviously A equals C. So, and we'll be returning 20. Else if 2 of the numbers are the same, we can actually do this. We actually don't have to check to see if 2 of them are the same. What we can do is A not equal to B and B is not equal to C and A not equal to C. Well, that means none of them are equal. So we can return 0, else return 10. This is the default case. Now if they are not all different and they are not all the same, then 2 of them have to match. So the logic for finding out if 2 of them matches would be a little more verbose. We can do that. So let's say return 0 as our default, and let's return 10 if 2 of them are the same. And the logic for that would be, man, that'd be kind of long. Let me see. So if A is equal to B, it don't have to be that long, or B equals C, can we use a string of exclusive ORs? I think I can only compare 2. But I'm not sure, so let's go ahead and try it out. And it works, really. That's interesting. The exclusive OR can work with multiple comparators there. I wonder if I use the inclusive OR, some of it would fail. I would think. No, none of them fail, really? It might be that some of the tests, they just don't give the cases that would cause the test to fail. I'm not sure about that one. That might warrant some more looking into. And I think we're almost done. Yeah, we just have a few left. Blue ticket. You have a blue lottery ticket with ints A, B, and C on it. This makes 3 pairs, which we'll call A, B, B, C, and AC. Consider the sum of the numbers in each pair. If any pair sums to exactly 10, the result is 10. Otherwise, if the AB sum is exactly 10 more than either AB or AC sums, the result is 5. Otherwise, the result is 0. This sounds really complicated, but when you break it down, it's actually not that hard. So, 3 pairs. If any pair is exactly 10, so if A plus B equals exactly 10, or let's try B plus C equals 10, or A plus C equals 10, then the result is going to be 10. And let me see, otherwise, if any pair sums exactly 10, result is 10. Otherwise, if the AB sum is exactly 10 more than either BC or AC sums. So exactly 10 more, so AB minus 10 equals BC or AC. So A, B plus C, and I think we need some more enclosures here, or AB, it's A plus B. Okay, and A plus B BC or AC. So A plus B minus 10 equals A plus C. And then the result would be 5. And note that you don't actually need the A here. As an equation, you can remove A from both sides, and it's the same thing. So, and then otherwise the result is 0. Oh, missing a bracket somewhere. Let's see what we've got. Okay, this one matches with that one. Matches with that one. Where's our missing bracket? A plus B equals 10, B plus C equals 10, equals 10, if, else if. I'm wondering about these. Yeah, that's it right here. See, we need parentheses enclosing the entire if. There it is. See, and then what I said about this as an equation, you've got, if you remove A from both sides of the equation, it's still the same. See? Okay, and share digit. Given 2 ints, each in the range 10 to 99. Return true if there's a digit that appears in both numbers, such as the 2 in 12 and 23. And then that gives us this big hint here, and I discussed that earlier. Integer division, n divided by 10 gives the left digit, the tens place digit, as these are all 2-digit numbers, while the modulo in modulo 10 gives the right digit, the ones place. And of course this holds true for integer division up to any place value. So x divided by 100 gives you the third digit from the right, the hundreds place. X divided by 1000 would give the fourth, and so on. So pretty easy, just a comparator here. So return true, so return, and that would be A modulo 10 equals B modulo 10. Okay, or A divided by 10 equals B divided by 10. Or, as it says here, the 2 in 12 and 23, 2 in 12 and 23 it would be A modulo 10 equals B divided by 10, or A divided by 10 equals B modulo 10. So it looks like it could be really complicated. We can actually get it all done with just the one line of code. And this is, let me see. The logic is exactly the same here, but they just took the trouble of inserting the values into these, whereas we did not do that. We just wrote them out the long way. So I do warn against trying to golf things too much. Generally, if you try to compact something too much, it's going to harm the readability, and it might use, sometimes they're using weird, obscure programming tools that might not even increase the efficiency of the code. But this is by no means too compact to be readable. It's clear what's going on there. Sum limit, given two non-negative integers a and b, return their sum so long as the sum has the same number of digits as a. If the sum has more digits than a, just return a without b. So long as the sum has the same number of digits as a. Okay. One way to compute the number of digits of a non-negative int n is to convert it to a string with string value of n, and then check the length of the string. Okay, so what they're saying here is, let me see, so long as the sum has the same number of digits as a. So we're looking at a for our limitation on the number of digits. So what we do is int, let's just call it length. I don't know, I don't like the length. Let's say digits. Digits isn't a word that's used. As far as I know, digits is not used in as a method or anything. So int digits, and we're going to assign the value of that, and it's going to be string value of n. Oops. Should be length. Let me check on that. Okay, now our return type is an integer, and this is an integer that we're declaring here. So it shouldn't throw an error because it's expecting the wrong data type. Now these tests aren't going to be correct, but I just want to make sure I did this right. Cannot find symbol. Oh, n. It's not n. It's a. It's a. There we go. So this should work. Okay, so this is a. How many digits is that? It's 1. 1, 1, 1. Okay, this one is 2. This one is 2. Here we got 3 digits. 8 digits. Okay. Okay, so we know that this works. Okay. So now from there we're going to, if string value of a plus b, there's the string value of, and then length, remember the empty parentheses, if that is greater than digits, what do we do? If the sum has more digits, then they just return a without b. So return a. Otherwise, we return the sum, return a plus b. And there it is. This, I knew that this function existed, this method certainly existed. I knew about that. I would have had to look it up to get the exact phrasing, value of in, yeah. And then of course they didn't tell you that that is the string value of. So what that does is that converts, say right here, 123. 123 is an integer, 123. Okay, but we need to know how many digits it has. What we're doing is we're converting that integer into the string of 123, which is different from the 3 characters 123. That is different from the number 123 as an integer. Now, because it's now a string, we can call the length method on it to find out how many characters are in that string. So that's what we're doing there. Oh, is that it? I think we're done with the logic. Logic 1 is finished. Right at about 36 minutes. So good time to wrap it up. And what are we doing next time? Logic 1. Looks like we can go, I think we'll do Logic 2 and then go on to some more advanced strings after that. Thanks so much for watching. As always, like, comment, subscribe. Any questions or requests are welcome, of course. And we'll see you guys next time. Thanks. Bye-bye.